experiments. So we're looking at this practical for tomorrow. So there are three major things you will see. We have mechanics. The first one is mechanics. Second one is heat. And the third is electricity. So out of these three, you have to answer two questions from these three. Okay, so what I normally suggest, question 1 and 3 are normally okay to do. They are easy and direct. So the question 1, they bring some apparatus. Let's take number 1 first, mechanics. So under it, they gave you 2 resistor stands, the apparatus involved, 2 resistor stands, 2 resistor stands. Then 2, we have set of masses. Set of masses range from 100 grams to 350 grams. Then you also have number 3, meter rule. Number 4, we have a spiral spring. Okay. Number 4, we have spiral spring, and then we have we also have a plasticine. So the experimental setup is something like this. You have your resource stand here, although I'm not sure yet, because NECO, WAEC are very difficult to predict. So this is spring. This is a spring like this, fixed to a meter rule. This another resource stand will be here, in this manner. This is a spring, fixed to a meter rule like this, at a certain point. So the mass will be here. Okay, maybe
yes,
start with starting with 50 grams or 100 grams. So you have to oscillate this thing to and fro. Okay, you'll be going up and down for 20 oscillations. So when you record 20 oscillations, you have to record the time t. Then after which you now add another 50 gram mass to become the time mass you are adding now is now what? It's now 150 grams. You also oscillate it. Okay? So give you another time, maybe for 20 oscillations. You give you another time t. So you have to record the period, record the time, calculate the period, and plot the graph. That is eventually the whole concept. So the reason why we are here is to teach you how to plot the graph. Because if you don't plot a nice graph, you cannot pass physics exam. The major thing is the graph. The graph, it will go along. We have to use it to answer some questions. Not only plotting, you use it to answer some questions. If you fail to plot a good graph, your chances of passing the exam is very slim. Okay, so what I will do now, I'm going to include some certain values. Let's try to use it to know how to plot graph. Now, before, let me describe how the graph look like. This is how your graph look like. I want to make a sketch of it. I want to make a sketch. I think I've taught you before. I can't remember. I don't know if I've done that before. I want to make a sketch of the graph. So under here, you see lines like this. It's always 5. Here too, it's always 5. See that? This is how your graph look like. So if you count these smaller buses, here is a single bus like this. Here is a single bus. Under the single bus, we have 2 smaller buses inside. Do you understand? Hello, I don't know if you can hear me. Hello, can you hear me? Good luck. Good luck, can you hear me?
Yes, sir.
Okay. So you just joined this class now. So let's continue with it. So the reason why we are here, primarily, is for the graph.
Mm.
Like I said, without the graph, your chances of passing the exam is hard, very hard. So I'm going to put, I hope you have graph with you there.
Yes, sir.
I'm going to impute some values on the board. Okay, like number three. Number three, I will impute the value on the board. If this come like that, if the what's it called? If the circuit, if they say the circuit the way I drew it, you can use the value tomorrow. So all you have to do is to face your number one. In number three, we're going to use it to perform the experiment. To plot the graph. I'm going to use number three values to plot the graph. I've conducted the experiment before, so it might come in different form, but like what I'm saying, if you call the way I drew the circuit, then the values are true. I use the values. Okay. So let's go to the graph. Now, when you see a box that contains 5 smaller boxes, this box is called 1 centimeter. This size is also 1 centimeter. Are you getting it? A single box that contains 5 smaller boxes, it is referred to as 1 centimeter. So if for a graph, put this in mind. So if you need 2 centimeters, then you need to pick an extra 1 centimeter from here to here now. It's now what? From here to here now will now give us 2 centimeters. Abi?
Yes, sir.
2 centimeters. So anytime you want to plot a graph, always use 2 cm. It's very important. Always use 2 centimeters. Then the units, you must pick a scale. You must say scale. You have to write scale. If you don't do this, scale, you now write vertical axis. We don't have y-axis in physics. Scale on vertical axis. Physics does not recognize anything called y. Do you understand? Don't recognize it. So your scale always speaks 2 cm, 2 centimeters. So I've told you from here to here now is the 2 centimeters. From here to here now is the 2 centimeters. Then to represent what? 2 centimeters to represent unknown unit. Let me say X unit. I don't know what the unit is. So there's no way you can just use any unit you like. The units you are using, it depends on the table of values that you have. Do you understand? The unit you should be using depends on the table of value. The table of value will tell you, okay, I'm using so-so unit, or I'm using so-so unit. So you must take the scale on both sides. You also write scale on scale, okay, say horizontal axis. You must state both of them. As this thing goes for 2 marks. If you don't state, you think it's irrelevant, you are going to lose the 2 marks. You also say 2 cm to represent, let me say m units. So do you know I'm using m and x? Because I don't know, I don't have a table yet that that I will use to choose the unit. I don't have a table yet. Are you getting it? The table you have will determine the scale, the unit you should use. But the 2 centimeters is established. From here to here is 2 cm. The reason why we are using 2 cm is that if you are plotting your graph, your graph should not fall below. If this is the full graph now, and this is half of the graph. Your graph must exceed half. It must exceed the half, or at most it should be up to the half. Anything above half, anything below half, we lead to deductions. We need to deductions of marks. So that is why we are using 2 cm. With 2 cm, the graph will be big. Your graph will be large. Okay, that's why. So if you're plotting your graph, make sure it's above half of the graph, or just half of the graph, but it should not below half of the graph. Okay, it should not go below half of the graph. So you must put that to mind. You understand? So let's assume this is our table, this is our graph, okay? And we choose to use, for instance, let's choose a scale now. Let's assume I choose a scale of 2 cm to 1 unit, for instance. Let's assume I chose 2 cm to 1 unit. Okay? So meaning for every 2 centimeters, you are putting what? 1. So if this is your reference point, you must draw 2 axes. You must draw 2 axes like this and like this. Do you understand? You put your arrow head. Okay? You must draw 2 axes like this. So sometimes they don't use the word. Sometimes they don't use the word vertical axis. Sometimes they don't use the word vertical axis. They use the word ordinate in place of vertical. So where you see ordinate, it's representing a vertical. Therefore, horizontal, they use the word abscissa. Abscissa to represent the horizontal. Do you understand? So pay attention to these two terminologies tomorrow. So the ordinate is Y, the abscissa is the X. So take note. So if this is our graph, so you have to label here. You will label these points based on the value you have now. You will label based on it. For instance, now here is you don't just say if they say the graph started from started from the origin. If the question say the graph starts from the what? From the origin, you must label here as 0, 0. What does it mean? The horizontal axis started from 0, the vertical axis started from 0. Is that clear? That is what you must do. So let's assume you have to use 2 cm. You are using 2 cm to 0.2 units, for instance, based on the value you have, 2 cm to 0.2 units, for instance. It simply means that for every 2 centimeters, I'm putting what? 0.2. Take, for instance, from here to here is 2 centimeters. So I will write 0.2 here. From here to here is another 2 centimeters. I will write 0.4. That means it will be increasing. Let as though the thing continue. It will become what? 0.6. It will be increasing by that factor until you get to the point you want. Okay? Then let's assume on the horizontal axis, say use 2 cm to 0.1. So for every 2 centimeters, I'm putting 0. So from here to here is 2 cm, I'll put 0.1. From here to here is another 2 cm, 0.2. From here to here is another 2 cm, 0.3. So this is how you'll be right until you get to where you want. Do you understand?
Yes, sir.
Pay attention to this very carefully tomorrow. Without a good graph, you go nowhere. So this one is also 5 points. 1, 2, 3, 4, and 5. So all these ones are 5.2. 1, 2, 3, 4, and 5. This is how your graph normally looks like. So I hope the centimeter, the unit explanation is clear.
Yes, sir.
So let's assume now you have a table. You have a table like this. You have a table. Let's use SIY to represent our horizontal and vertical. But like I told you, physics don't recognize what is X and Y. So let's assume you have 0.24. Here you have 0.16. Here you have 0.42. Here you have 0.31. Here you have, for instance, let me say you have here 0. Okay. Let me say here 0.22. Or let me see 0.22, here 0.24. So let's increase it. Let me say here 0.31. Let me say here is 0. Let me call it 21. Let me call it 0.34, for instance. Okay. Now, if you go back to the graph, there's nowhere in the x-axis. Let's assume these are x. Like I said, they don't know what is x and y. Tomorrow, they will tell you what to put on the horizontal. As you are putting it, you are putting the SI unit. Maybe if the SI unit of x, if the SI unit of the horizontal is ampere, okay? As you are writing it, you come here to write /ampere. If the SI unit of the vertical is volts, you come here to write open bracket V. If you fail to do that, you lose 1 mark. Each of them is half. Because if you fail to put it, it simply means you are plotting a meaningless graph, a graph without meaning. Because they don't know who is y, what does the y, what unit the y represent. They don't know the unit x represents. For that reason, you are plotting a meaningless graph. So you must state the units on both sides of the graph. Is that clear? You must state it clearly. If you do that, you get yourself 1 mark or 2 marks. I'm forgetting the rating. Now, go back to what we are saying. So let's assume we have 0.22, 0.24, 0.31, 0.16, 0.21, 0.34. Now look at the table. Look at the graph. Is there anywhere we label 0.21? Then we label 0.22. Then we label 0.31. Nowhere, right? Hello? Hello, can you hear me?
Yes, sir.
Okay. So there's nowhere we label those values. Those values are not labeled according to the question. So we don't have any such value there like that. So how do you count? The question is now, how do we count the 0.22, 0.24, 0.31 on the x? How do we count this on the x? How do we count this on the y? So to do so, see, good luck and the figure. Let me tell you something. Let me make it as simple as it is, with some touch of reality. It is only a fool. It's only, let me use the word. Let me put it on the board. It's only a fool that will plot physics graph without doing what I'm about to show you. It's only a fool that does that. Or somebody who has planned, okay, I want to take this exam. That's when the person will know what I'm about to show you. Do you understand? So now, if you look, if you notice, let me redraw this. This graph. So we have how many points? 5. Okay. So it continues for all of them, 5 points. So it continues, all of them. If you count your graph and check if that is the case. In one bus, you have 5 smaller buses. count it and tell me if that is the case.
Yes, sir.
So it's very important. You have things like this. So I've told you one bus that contains 5 smaller buses is called how many centimeter? We agree is 1 centimeter. So let's assume now this is our graph now. I will now draw my vertical axis. I will draw my horizontal axis. So I will put my arrow at 0, 0, just in case, because of say the graph starts from the origin, which is 0, 0. So I label here 0 point what? 0 0.2, 0 0.4. And if I have put on that one, it becomes 0 0.6. So here, 2 centimeter, here 0 point. What do we choose? Which scale do we choose the other time? Okay, 0 0.1. So here now, let's take here you have 0 0.1, 0 0.2, and the rest. So here 0 0.1. Here's under 2 centimeter, 0 0.2, under 2 centimeter, 0 0.3. So it continues. Right? So this is the point I'm about to say. It's only a fool that will start plotting points on the graph without doing what I'm about to show you. So this is what you do. Now, there's nowhere in the graph we have all this value here. This is 0.22. There's nowhere we have. Is there anywhere we label 0.22 on this graph?
No.
No. So how do we count 0.22? This is what determines whether you fail or pass. Because for each point you mark wrong, they will deduct a mark. And for each point you mark wrong, they deduct marks. So this is what will tell us whether we have to pass the exam or fail the exam. So now all these buses, you see this bus, they are countable. If here is 0.4, if here is 0.2, and here is 0.4, one bus is now what? Remember, all these are, there are one buses here. So if one bus is 0. If here is 0. Here is 0.4, one bus is now what? You see that? You have to know how to count each of the individual buses. In that bigger bus that make it 1 centimeter, you have to know how to count it. To do so, we have a formula that says one box is difference. Okay, let me not stress it. One bus is the unit you are using, the unit I picked over total small boxes. Over total small boxes. So let's go. For the first one, for the vertical axis, what unit do we pick? 0.2. Is that not?
Yes, sir.
So how many smaller buses are there in that 0.2? How many smaller buses we have for the 2 centimeter now, for the unit, difference between the unit now? How many buses are present there? How many smaller buses are present there? 10, Abi?
Yes.
So it's 0.2. So I'm having 0.2 divided by what? 10. So one box on the vertical axis is now what? 0.02. This is for the vertical axis. Then what about one box on the horizontal? One box on the horizontal will be what? The unit we use horizontal is 0.1 divided by 10, which is 0.01 on the horizontal axis. You can see you cannot have the same value except you are using the same unit for both the vertical axis and the horizontal axis. That's the only way you can have the same value as the value of a box. If the unit you are using is the same. If you are not the same, you must do this calculation for both the horizontal and the vertical. If you don't do it, don't bother plotting any point because you are going to lose all the marks. That's why I say it's only a fool that will continue plotting points without doing what it's supposed to do by making these calculations. Is that clear? So let's go back now. So if here is 0.2, here will be what? Here is 0.2. Now don't forget. Here is 0.1. One bus is now what on the vertical? 0. What? 0.02. So if I count this one bus now, what am I having? I'm starting from 0.2, and each bus is 0.22. So we're having 0.2, 0.02. What's our answer now? Here is 0.22. You see it? So each bus, if I count one bus now, it will move from 0.2 to 0.22. If I count this one, meaning I'm adding 0.02 to this. I will add up. So if I count this one, I'm having what? 0.24. Then if I count this, I'm having 0.26, 0.28. Here is now 0.3. So if I count this one, now it becomes what? 0.32, 0.34, 0.36, 0.38, 0.4. Are you seeing it? I hope it's clear. Then let me see, maybe 5 points. Here is 1, 2, 3, 4, and 5. So let's also apply the same knowledge for the horizontal. The horizontal now bus is what? 0.01. So if I'm starting from 0.1 and I choose to count this bus, meaning 0.1 plus this bus. So I'll be having a 0.1 where I'm starting from. Where I started from 0.1 plus 0.01. If I add up, here's 0.11. That means if I count here now, I'm having 0.11. If I want to count the next one, a matter of adding 0.01 to it. Here is now 2, 1, and what? 0. So if I count the next bus, here is 0.12, 0.13, 0.14, 0.15. If I count this 0.16, 0.17, 0.18, 0.19, 0.2. Are you saying that? Is it clear?
Yes.
So when they say you should count, 0.22 on the x-axis is very easy. How do I count 0.22 now? I know that a box on the x-axis is 0.01. Let me make here now 2, 3, and 4. So if I want to count 0.22, how will I count it? There will be 0.21, 0.22. Are you seeing it? That point time is 0.22. So you have to follow that point until you get to what? 0.16 on the y. You have to follow that point to get to 0.16 on the y. Where's my 0.16? So here a bus is what? 0.22 here. Here 0.22, 0.24, 0.2, 0.02, 0.02, 0.04, 0.06, 0.08, 0.1. So let me complete this one and see. There are 5 lines here also. 1, 2, 3. Okay, let me put 4 here. So I'm using 0.1. So here's 0.1 now. There will be 0.12, 0.14. Here's now 0.16. So as 0.22, I will follow that part up. So I get to 0.16, which is this point. Let me extend it. Which is this point. I'll follow this part up now. And if I get to this point, and I get to this point now, you asterisk it. This is the point where the two meet. So let's go to the next one. Here is 0.24. Here is 0.21. So let's look at 0.24. So here is 0.22, 0.21, 0.22, 0.23, 0.24. So my here is my 0.24. The other one is 0.21. I will go up. I will come here now. Here is 0.2. But a box here is 0.02. So you have to use your discretion. Let me show you. You have to use your discretion now. Okay? If you notice, you cannot count. Let me draw it somewhere else. Look at what we have now. 1, 2, 3, 4. 1, 2, 3, 4. So let's assume here is the 0.24. I'm looking for 0.21. Okay? And here is, let's assume here is 0.2 now. So if I count this one, it will be 0.22. But what I want is 0.21. What I'm looking for is 0.21. You see that? So, so that means I cannot mark it. I cannot mark it here. I cannot say here is a point. No, if I mark it there, I'm marking it at 0.22. I'm marking it at 0.22. So we have to use the discretion. You see this, you have to find the half of this point, the half point now. That's where you mark. You have to use the discretion to locate the half. That's now your 0.21. Because the full one, the full box is 0.22. The half of it will be 0.21. Is that clear? Then let's assume you have 0.207. 0.207. Let's assume now. Or 0.201. Here is 0.20. If I count here, 0.22. So if any number you know you cannot count, just mark it as the first three. I will mark it here. If I know I cannot count it, I will just mark it as 0.2. You understand what I'm saying? Anything you know you cannot mark, just mark it as the original number before the decimal. As in, mark the first decimal. If you know you cannot count it. I cannot count 0.201. So that means I will mark it as 0.2. But if you can count it, you have to count and mark. Do you understand?
Yes, sir.
Is it clear?
Yes, sir.
Okay. So let me put, let's try something else. I told you before, I will do this number, let's do this number 3 together. But if you see the circuit diagram like that, that means you are very lucky. But like I said, physics exam are not predictable like WAEC. Fejiro, can you hear me? Fejiro.
I'm hearing you.
So if you remember when I taught you the chemistry, I told you this is exactly the question. This is exactly how the question will come, and that is the way it came out, Abi.
Yes, sir.
But physics is not like that. So, like I said, if I can draw the circuit diagram, and it came out the way I'm saying it, that is the value. So you can go ahead and write it. So just memorize it just in case it come out like that. So let me impute let me first of all draw the circuit diagram and impute the experimental values. Let's see. So if you have, all the circuit is connected in series. So we have the ammeter here. Then you have your EMF, which is 1.5 volts. What you see there is E. You see E there, not 1.5. Then you see something like this. They stroke it. You see ROH. It stands for rheostat. Then you see all this line I'm drawing, they are wires. Okay? You see a point here, point A. Then you see your voltmeter here, V, connected to another point here. And you have your ROS. The value of this ROS is 2.0 ohms. But you will not see 2.0 there. What you see is ROX. Then you now see your key in this manner. This is your key. So then you see a point like this. This one is not meeting it. Okay? Yeah, so here is now a length L. There is now point B. So point A and B are constantan wire. Constantan wire A. The other one is constantan wire B. Okay. So and now the next I'm about to write is correct. Whether the table come like whether the circuit come like this or not, you can write this I'm about to write next. They will ask you to measure the diameter. Measure the diameter of this wire. They will ask you to measure the diameter of this wire and also the diameter of this wire using your micrometer screw gauge. They will ask you to use micrometer screw gauge to measure the diameter of constantan wire A and measure the diameter of constantan wire B. So for the A, our DA, diameter, which is DA, the value is, because I actually bought the constant wire, the value is 0.38 millimeter. So these values are correct. The VB, diameter of constant wire B is 0.27 millimeter. So we are dealing with question 3 now. These are the value for the constant wire when you measure it with your micrometer screw gauge. Then the table, just in case, this is how the table comes out. So you have your serial number, which is the number of times you are performing the experiment. This is the length of the constant wire in centimeter. The length is in centimeter. Then your ammeter, the ammeter you are asked to use is measured in milliampere, not in ampere. It's measured in milliampere. Then you need to, from there, you need to record your voltmeter in volts. Then record your resistance of X. Resistance of X will be V over I, also in ohms, according to Ohm's law. This is for A. This is for A. Okay, let me erase this one. This is for A, so that you don't get confused. You have to draw two tables tomorrow. This is for A. So how many times are you going to perform the experiment? It's 5 times. Label it 1, 2, 3, 4, and 5. You are performing the experiment 5 times tomorrow. Okay? From the measurement, we are starting with 100. Make sure all your values are to 2 decimal. But if you are using 3 decimal, now I cannot use 2 decimal here. I use 3 decimal here. No. Or every column should be the same decimal. Do you understand? If you want to use 2 decimal in any place, use 2 decimal. If you want to use 1 decimal, but the minimum should be 2 decimal. They don't use 1 decimal in experimental values. Do you understand? The minimum should be 2 decimal. So if you are using 2 decimal in any place, use 2 decimal. If you are using 1, use 1. So no, use 3. So the first one we are using 2. The length of the constant wire A now is 100. We are assuming that we are starting with 100. Followed by 90, followed by 80, 60, and 70 and 60. So when you do that, and you carry out the experiment, the ammeter will read 67.00. At 100, it will read 69 at the second value. It will reach 70 at the third value, just like that. Then here will be 72 and 74. Then at the same time, the voltmeter at 100 will read 0.38. The second will read 0.35. The third will read 0.33. The fourth will read 0.30. And the fifth will read 0.28. Then to get your ROX is V divided by I. Okay? Is V divided by I. So what is your V now? Now, if you look at here, it's in ohms. For you to have ohms, is volt over what? Ampere, not milliampere. But the unit here is in what? Is in milliampere. So how do you convert from milliampere to ampere? You divide it by 1000. Do you understand? So before you calculate the resistance, you need to divide each of these values. You need to divide each of these values by 1000 before you can use it. Do you understand? That's how you convert from milliampere to ampere. So let's try it. Divide 67 by 1000 and tell me what you have. Then divide 67 by 1000 first.
Zero point zero six seven.
0.067. So use the voltage line is 0.3. So use 0.38 to divide 0.067. Tell me what you have. 0.38 to divide 0.067.
5.67.
So approximately 5.70. Because not, if we want to write 5.67, we write 5.67. You can still write it as this. Okay? You can all approximate it to the nearest whole number, 5.70 or 5.67. It's your choice. You understand? Then also do the same thing to the second one. If you do the same thing to the second one, you're going to have 5.10. You're going to have 4.64. You're going to have 4.20 and 3.70. So please copy this table before we go to the second consistent wire B. Copy this table.
Sir,
Yes.
how will we get this value tomorrow?
It's through experiment. You have to connect the wires according to the diagram. Like let me show you. Now, if you look at this thing, this is the battery. You will see battery tomorrow. The EMF is your battery, a Tiger battery. Do you understand? Here is the ammeter. You see a device like this. You see a device like this. You will see A here, represent ammeter. Then under it, there are two terminals. You see a terminal like this and a terminal like this. Then that means this is a wire. This wire will come here. This wire will come here. Are you seeing it? So then you will turn on that wire here, which is for the key. The key is something like this, with small opening. And you have a plug. So you also use to plug inside like this. That will be here on the key. And you have two terminals too. One terminal is here, one terminal is here. So one wire will be here, one wire will be here. This wire will be here. Then you see a resistance, something like this. Are you getting it? So meaning this wire that is leaving here, it will enter here. The other one will leave this side. You also have terminals. So you connect this wire to the constant wire B. Then for the constant wire B, both of them, you tie both of them together here. Then you connect it to the voltmeter. The voltmeter is something like this also. But you have two terminals too. This one will come here. This another terminal will come here. You connect, you stretch on that wire here. Then the rail starts. You see something like you can browse it and see how the shape of it. You know what a rail start is. You connect one wire here, like this. Then you connect the rail start to this wire that's coming here. Then to another constant wire B. Connect to constant wire B. Then also you have to measure this length. Okay. Then at the end of it, if you want to do the experiment, you have to lock the key. You lock the key here. They use this two wire to touch the battery. This thing will deflate. It will deflate like this. It will deflate also. You take the radius of these two. Do you understand? That is how you have to perform it. So, like I said, all these ones is something I've done before. I've done, I formulate, I've done. So if the table come like this, you can just write these values tomorrow. Okay? So that is how it's got, you get it through experimentation. If you are done, let me know.
I'm done.
Okay. So zero.
Done.
Okay. So let's do for the second constant wire B. But for the second one, this is what you are going to have. You got the same table. You got the same table. You have your serial number of times the experiment will be conducted. So diameter of second constant wire DB. That's the diameter. Now you gather diameter using a micrometer screw gauge. I hope you know what's a micrometer screw gauge. That's what you use to get the value, a micrometer screw gauge. So for this, diameter is of the constant wire B is 0.27 millimeter. That is diameter. Then you see you're going to have the length in centimeter. Now, anytime you are writing on this thing and you fail to put the unit, they will deduct mark ammeter in milliampere. Then voltmeter is volts. If you fail to put this unit, you are losing mark rapidly. So here is okay, let's call the first one. Let's call the first one arrow A. Change to arrow A. Let's call the second one arrow B, which is also V over I in ohms. So the first length we're also using here is 1. Second experiment, third experiment, fourth and fifth. We're also using 100 cm, 90, 80, 70, then 60. So if you do the same thing using the second constant wire, the first ammeter here we read the first one we read 59.00. Okay, here we read 61.00, 63.00, 65.00, then 67.00. Then the voltmeter here we where we read 0.53, here we 0.50, then here's 0.48, here's 0.46, here's 0.40. No, here's 0.43, not 46, 0.43, 0.40. So if you do the same thing by converting the ammeter to ampere, dividing by 1000, then use 0.53 to divide it, I'm going to have here will give you 8.90. So people can change it to 9.00, approximate it. It's the same. So here will give me 8.20. Here is 7.54. Here is 6.54. This will give you 5.97. Some people can also here to 6.00. It's the same. Okay, when it's very close to where your approximation is very close to the number 5.96, 5.98, you can just take it to 6.00. Okay, so this is the second reading. Like I said, these two values are correct, irrespective of how the circuit comes out. This diameter, the other diameters are correct.
So are we going to plot graph for this?
Yes, so I'm going to plot it. Yes, I'm going to plot it. I'm going to plot the graph.
I'm supposing to graph.
No, it's one graph. It's one graph.
Now I'm saying the mechanical and the electricity.
Yes, yes,
graph
yes,
now.
yes. You plot graph for both. Yes, you plot graph for both.
Are we plotting graph in this?
Brother,
Are we
I didn't get
plotting
you.
graph in this part?
In the number 2.
No, this is practical. Are we plotting graph?
Yes, now that's not, if you are not plotting, if you did not plot a graph, you can't pass the exam. You must plot a good graph. Take your slope and the rest. Now you can't pass. You must plot a good graph. If you are done, let me know.
I'm done.
Okay. Okay, so what they will ask you, they will ask you to plot a graph of arrow A against arrow B. You have to draw two axes like this. Okay, you come here, here's your arrow A. You must put the units in ohms. Here's your arrow B, also in ohms. If you don't put that, you lose mark, like I said. Do you understand?
Yes,
You lose mark. So let's see now, based on the table we have, what scale will you use for arrow A? What one unit will you use? I told you already use 2 centimeters. For 1 unit, are we using in the arrow A? If you want to consider your units, you consider the highest value and you consider the lowest value. Anytime you want to consider unit, consider the highest and consider the lowest. So who is the highest value here? The highest value is 5.7. And who is the lowest value? 3.7. So like I said, that is for arrow B, the highest value, let's take it as 9. The lowest value, let's take it as 6. Are you seeing it? So that will determine how you will take your units. Like I said, always use 2 centimeters. So after drawing this line, the next you do is to come and write K. You have to write K on vertical axis. Which of the vertical axis, the open bracket, is arrow A. Put it like this. You see it? It's equals to 2 centimeters to represent. Now, look, let's go back now. Which scale can you take now on the arrow A? 1 unit can you take? We are taking this 2 centimeter array. 1 unit can we take? Is it 1? Is it 0.5? Is it 0.2? Is it 3? Is it 4? So name it. So suggest for me 1 unit can you take on the arrow A? Make a suggestion. Let me hear.
0.5.
Okay. So what you do not, look at what you're going to do for me. Good luck. So count your graph. If we accommodate all this value here based on 0.5, count your graph. For every 2 centimeters, you put 0.5, count it. If we accommodate up to 5.7, count, let me see. After counting it, tell me what you have, whether you accommodate all of them or is not enough. Count it, starting from 0.5. To every 2 centimeters, you put 0.5. So do that for me, and count.
Yes, sir. Yes, sir. Is enough.
It's enough, right? So if it's enough, you can use it. So, but if it's not
sir,
enough, that means, yes.
the graph they're going to give us for the practical, is it a 2 centimeter graph or
Yes, it's
1
a 2
centimeter?
centimeter graph. No, it might be 2 centimeter graph, might be 1 centimeter graph, but it doesn't change anything. Do you understand?
So you know that most 2 centimeter graphs are very large.
Now let's go back. Let's go back. For the 2 centimeter graph, this is what you see. For For 2 centimeter graph, you're not going to see this line there. This line will not be there. Then this one will not be there. You see it? It's just from here to here now, 2 centimeter, 2 centimeter, 2 centimeter, just like that. You see that? Sorry, from here to here, I mean, here to here is 2 centimeter now, like this now. But this line and this line will not be there. So you just have straight stem boxes without the middle one. Do you understand?
Yes, sir.
That line will not be there. So it's enough, Abi. So you have to write 2 centimeter to represent. You have to represent 0.5 ohms. Because the unit of the vertical is in ohms, Abi.
Yes, sir.
0.5 ohms. So you also take K. So to write K on horizontal axis. K on horizontal axis, which is my arrow B. I told you already use 2 centimeter to represent what? To represent check. Centimeter to represent. So let's check the highest value and the lowest value. So the highest value here, let's take it as 9. The lowest value, let's take it as 6. So what unit can you use here on the arrow B? Huh? What unit can you use on the arrow B? The highest value is 9. The lowest value is 6.
One unit.
1 unit.
Yes.
Okay, count it if it be enough. Adapt it. Count. Count your gravity to be enough. For every 2 centimeters, you put 1.
Yes, sir. It will be enough.
Are you sure?
Yes.
Are you sure you are counting it very well?
Yes, sir.
Okay, because at the end of the day, you are going to snap the graph for me. Let me see it.
Okay.
You are going to snap it for me. So are you done? So 1 ohms. Okay? Hello? So what you do now is this. What you do now is this. You come now, you label here 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. You count until you get to what? To 5. So here you now come 1 for every 2 centimeters, 2, 3, 4, 5, 6, 7, 8, and what? 9. For every 2 cm. This is what you do. Is that clear?
Yes, sir.
Okay. So after doing that, help me calculate like I said, don't plot any points until you calculate the value of a box for both the horizontal and vertical. So help me calculate the value of a box for the horizontal and the value of a box for the vertical. Do that.
For the vertical is 0.05, for the horizontal is 0.1.
Okay, so start plotting the points now. Start plotting the points of arrow A and arrow B. Start plotting them. When arrow A, when you start, you move from the, look at this is done. You move from the horizontal to the vertical. So you start, when your arrow B is 8.9, or let me say 9, what is your arrow A at that point? Your arrow is what? 5.7. Do you understand?
Okay.
So what I will do now, as a 9, I will move till I get to 5.7, I'll steric that point. Starting from you move like this from the horizontal to the vertical. So you consider the value you have in the arrow B and the corresponding value in the arrow A. But you consider the arrow B, you move from the arrow B to the arrow A. You move from the horizontal to the vertical. Now do that, plot all the points and send me the graph. If you are done with the graph, let me know so you can determine the slope. Are you done? Good luck. Are you done? Hello, good luck.
So I'm not done.
Okay. Okay, see, let me just explain something to you. Because of my battery, so my battery doesn't off against me. For instance, let me just explain something to you so that when you finish doing it, you can send to me. Okay? So let's assume you plot a point here, you plot point here, you plot point here, you plot point here, you plot point here. After plotting on this point, you have to look for the line of best fit. What do I mean by line of best fit? The line that takes one point. For instance, if I should rule this straight line, I will have 3 points. If I should rule this one, I will have 2 points. Are you getting it? If I should rule this, I will have 2 points. You see that? So the one that absorbs the most points is the line of best fit. So if you are ruling, you consider this one here. Consider this line here. This is not your line of best fit, not these two. So these two will not be among, not these two. Consider only those points. Are you there? That's what we consider. The line of best fit. Although all these points will be yours, but they are outside the line. You can circle them if you wish. Okay? So after taking the line of best fit, the next thing you take is your slope. How do you draw your slope? You draw a perfect, at any point within this line you drew, at any point within the line you drew, you draw a perfect horizontal line, a perfect vertical line, and a perfect horizontal line. Okay? This is not the, so you can write here delta ROA, which is the vertical. Then you can write here delta ROB, which is the horizontal. Is that clear? So what you do now, this is how you now calculate your slope. Your slope now write slope. It's often called x. You write is vertical over horizontal, which is delta ROA over delta ROB. So it become ROA, you put 2, which is first second value, ROA, the first value, over ROB, second value, ROB, first value. Now you come. What you do, you use your ruler, your pencil, to make a dotted trace like this to touch the vertical. You make another trace from here to touch the vertical. Then use another line, you trace another point from here to touch the horizontal and the horizontal. So let's assume it touched at 0.2 here. This will touch at point what? 0.5. So I'm going to have my slope now will be, slope x will be 2.0 minus 0.5 over, now trace the horizontal, now come to the horizontal. The horizontal, let's say here is 6, here is what? 1. And now have 6.0 minus 1.0. So you're giving 1.5 divided by 5. See that? So here is Ohms, here is Ohms. Ohms cancel Ohms. So your slope does not have units. And now, whatever you divide and have there, that's now your slope. Let's assume, let's assume we are plotting the graph of t squared against m, for instance. I'm going to have change in t squared over change in t squared, over change in m, which is t squared 2 minus t squared 1 over m2 minus m1. This one is second square, this one is gram. So your slope now, you write it as second square per gram. This will not be the unit of the slope. Let's assume you have it. This one will be your number 1 graph. This is how the slope will look like. Graph of period over mass. So this is the unit of your graph. Because period is measured in seconds, second square. Because of this square now, second square, mass is in gram over gram. That will not be the slope of your number 1. Is that clear? So take note. So this is what you have as your as a graph. So do this, determine the slope, and send to me. My battery is almost going down. Then I will send you some of the precautions you will write. Precautions for number 1 and precautions for number 2. I will send you for cram any 2. Take it to the hall. Okay? You write it tomorrow. As I cram any 2, as I'm sending it. And then learn how to define, how to calculate resistivity. Go and practice how to calculate resistivity. This is a topic in physics. The formula is this: resistance equals to resistivity length over area. So from here, you can, this is not this resistivity. Write it. Learn how to calculate resistivity. Then learn the definition of resistivity too. Definition of resistivity, learn it. There is one resistance, learn it. Learn on these definitions. Factors affecting resistivities. Factors affecting, all these things will come out tomorrow. Affecting the resistance of a wire. Factors affecting the resistance of a wire. Go and read them up. Okay, then how to define period, frequency, and yes, go and let me definition then, and the mathematical relationship. So I will send you the 2 precautions. Write any one of each. Out of the 2, question 1 and 3, I want you to answer question 1 and 3. Then you write the precautions. I will send it now. Memorize any 2. Okay? Memorize any 2. The first one I'm sending the precaution for number 1. The first one I'm sending precaution for number 1. And I will send, that is for the first, and that is for the mechanics. That is the experiment. So read it up. Write any 2 tomorrow. I'll send the first one. I'll send the second one. Okay. You will see tomorrow. You will see state 2 precautions you take during the experiment. You see those 2 things tomorrow. Have you seen the first one?
Yes, sir.
Okay. Read any, memorize any 2. You write it down tomorrow morning. I'm coming now. Let me share something. So if there are no, if I can't say it, number 1, write it down for, let me just state it for you. Let me just state it. Number 1, I ensure a tight connection of the circuit. I ensure tight connection of the circuit. Okay.
No.
2, I ensure the connecting wires are thick and short. Thick thick, are thick and short. And so your connecting wires are thick and short. So those two I know, you can just memorize those two. Then in addition to what I asked you to study. Okay.
Okay, sir.
So when you finish the graph, let me send it to me.
Okay.
All right, later. My battery is almost done.
Thank you, sir.
All right.